Hello everyone, how are you all? Hope you all are doing really good. So today in this video we are going to discuss a question based on row space, a topic from linear algebra. So in this question we need to check whether the given vector 5 7 minus 20 is a row space of the given matrix. So in order to check for row space, first of all we need to write the rows of the matrix given in the form of linear combination for the given vector. So if I write this, so solution, if we can write the given rows as linear combination for the given vector, then we can write this as a times row 1, which is 3 1 minus 2, 3 1 minus 2, plus b times row 2, which is 4 0 1, plus c times row 3, which is minus 2 4 minus 5. If we can write this linear combination for the given vector, which is equals to 5 17 minus 20. Now if we get values for ABC, that means that the given vector can be expressed as a linear combination of the rows of the matrix, so it will be a row space. Now if we solve for these equations, the matrix given to us, we'll take the transpose while finding the solution, because the equation is formed in such a way. So a shortcut way to remember is that if A transpose augmented B, the given matrix times augment the transpose of the given matrix augmented the given vector, if we are able to find a solution for the same, then it will be a row space. So now let us solve for the solution. So this will be equals to the transpose of the given vector, which is 3 1 minus 2, 4 0 1 minus 2 4 minus 5 minus 2 4 minus 5 augmented the given vector is 5 17 minus 20. Just give me a minute, guys. Okay, now let us solve further. So now we will reduce row echelon format, reduced row echelon form to solve the given equation. It will become easier. So now let us proceed with the solution. So first we'll apply a row operation, which is r1 is equals to 1 by 3 r1 to make this pivot 1. So we'll get 1 4 by 3 minus 2 by 3 augmented 5 by 3, and r2 and r3 they remain same, 1 0 4 and minus 2 1 minus 3. Now let us apply our second row operation, which is r2 minus r1, and at the same time we can also apply the row operation for r3, which is r3 plus 2 r1. So when we apply both these row operations, our element below the pivot element, which is 1 here, 1 is our pivot element, so elements below this they'll become 0, and that's what we want while reducing and applying reduced row echelon form. So let us solve further. So this will give us our r1 remains the same, 1 4 by 3 minus 2 by 3 5 by 3. Now we are applying the R2 minus R1. So that will give us 0 minus 4 by 3, 4, and it will be 14 by 3, and this will be 46 by 3. And our second operation is R2 plus R3 plus twice of R1. So this will give us, let us solve, 0, 11 by 3 minus 13 by 3 and minus 50 by 3. Now we need to convert this middle diagonal element to 1. So for that we can apply the row operation. R2 is equals to minus 3 by 4 times R2. So the matrix that we'll get by applying this will be 1, 4 by 3, minus 2 by 3, 5 by 3, 0, 1, minus 7 by 2, minus 23 by 2, 0, 11 by 3, minus 13 by 3, minus 50 by 3. Fine. Now again we need to convert 4 by 3 and 11 by 3 to 0. So for that, first in R1 we'll apply the operation R1 is equals to R1 minus 4 by 3 times R2, R1 minus 4 by 3 times R2, and R3 is equals to R3 minus 11 by 3 times R2. Now when we apply both these row operations, we get 104, 17, 0, 1 minus 7 by 2, minus 23 by 2, and 0, 0, 17 by 2, 51 by 2. Now we need to convert 17 by 2 to 1. So for that we'll apply the row operation. R3 is equals to 2 by 17 times R3. Fine. So we will get, after applying this row operation, 104, 17, 0, 1 minus 7 by 2, minus 23 by 2, 0, 0, 1 and 3. Now after this we need to convert minus 7 by 2 and 4 to 0. Actually I have row reduced the matrix in my rough notebook, so that is why I am directly applying the operations here, because I have solved them before, and I hope that you must be knowing reduced row echelon form and you will be easily able to solve the equations. But the main concept, I hope you are you understood that. So now let us further row reduce echelon form. So our next operation will be R2 is equals to R2 plus 7 by 2 times R3, and R1 is equals to R1 minus 4 times R3. Fine. So when we do this, we'll get 1, 0, 0, 5, 0, 1 minus 7 by 2, minus 23 by 2, and 0, 0, 1, 3. Now just a second, I did one error. So this will be 0, 1, 0, and we apply the operation here also, so we'll get 0 and minus 1. So we have reduced row echelon form our matrix, and our value of A will be 5, B minus 1, and C will be 3. So now as you can see that we started from here and we said that if we can express this matrix rows as a linear combination of this given vector, then it will be a row space for this matrix. Now we can also further get a question that expresses linear combination. So for expressing it as linear combination, we need to just replace the values of a, b, c here. So let me do that for you. So we need to copy this, and we also need to paste it here. Just a second. Oh. No. So we copied and pasted it here. So expressing as linear combination, express as linear combination. So we'll replace the values of a, b, c. So we got the value of a to be 5, b to be -1, and c to be 3. So we have expressed it as a linear combination too. I hope you understood this video and it was helpful for you. Do share with your friends, and once again I'll repeat the concept. So if we can express the rows as a linear combination of this vector, we can say that it is a row space, and the shortcut for this is that if A transpose augmented B, it gives us solutions, then it will be a row space. Thank you so much.